Okay, then we have here the blood indices. Okay, the blood indices includes your MCV, your MCH, and we have your MCHC. So these blood parameters would help us then to classify our type of your anemia. So ginagamit natin ito in order for us to classify what type of anemia it is. Okay, so the first one, we have your MCV or your mean corpuscular volume. So the mean corpuscular volume here is obtained as your hematocrit in percent over your RBC count in times 10 to the 12 per liter na okay, na unit of your RBC count multiplied by 10. Okay, normal values for your MCV, we have here 180 to 100 FL or your femtoliter. So if your MCV value here within 80 to 100 FL, we are considering that one as your normal CT. This is your, di ba, MCV as what we have discussed before. Your MCV here is primarily used for evaluation of your anisocytosis or changes in the size. Okay, so therefore, we consider this one as your CT, di ba, normocytic. Because an 80 FL, we classify that one as your, okay, microcytic. So we have discussed already what are the types of what are included in your microcytic anemia. If you have your more than 100 FL, that's your macrocytic. So this includes your megaloblastic anemia. MCH is another blood index. Although this one is not used here for classifying our type of our anemia. So MCH is just represent here the relative weight of your hemoglobin per RBC. So MCH or your mean corpuscular hemoglobin is obtained here as your hemoglobin in grams per DL over your RBC count times, that's the unit of 10 times 10, 10 times 12, times 10 to the 12 per liter times 10, multiplied by 10. So the normal values for that, we have 26 to 32 picogram. The next blood index, we have here the MCHC or the mean corpuscular hemoglobin concentration. So this would measure the degree of our anisochromia or defects with our hemoglobin content. Okay, so MCHC is obtained here as your hemoglobin grams per DL over your hematocrit in percent multiplied by 100. So the normal values for that, we have your 32 to 36 grams per DL. Okay, so again, less than 32 grams per DL, that's your hypochromic. This related also to your microcytic. Pareho lang din naman sila. And more than 36 grams per DL, we classify that one as your hyperchromic. As also seen here in your macrocytic anemia. So more than 36 grams per DL could be related to your hyperchromic macrocytic anemia. Could also be found here in the spherocyte. In the spherocyte here, hindi talaga siya more than 36 grams per DL. But it appears to be hyperchromic. So, mean to say, sobrang dark stain siya. So, your RBC appear to be full here because it appears to be like, that one is a spherocyte. So, medyo parang punong-puno ang hemoglobin content. Another one, more than 36 grams per DL here could also be found in cold agglutinins. So the cold agglutinins are your antibody which are reactive at the cold temperature. So to rule out the presence of your cold agglutinins, we just need to incubate your blood at 37 para ma-warm siya for 15 minutes. So if the cold agglutinins are present, that would be disappearing here after you try to incubate your blood at 37 for 15 minutes. Okay, then we have also here less than 22 grams per DL. Sobrang baba na nito, and that might be related to your lipemic sample even in the presence of your abnormal hemoglobin. Then we have here faulty centrifuge, mean to say defective the centrifuge. What are the parameters affected? If you are, again, like if you are doing the manual procedure, so number one, MCV. Why MCV? Okay, because may hematocrit tayo, gumagamit tayo ng centrifuge dito. MCH ba? Okay, so wala tayong hematocrit dito, hindi tayo gumagamit ng centrifuge in order for us to have the value needed for the MCH. For the MCHC is also affected by the effectiveness centrifuge when you're doing here the manual method because again, meron pa rin siyang hematocrit here. Because again, we are using hematocrit, we are using centrifuge for our hematocrit determination. And therefore, affected pa din also ang ating MCH with the faulty na centrifuge if you are doing your manual procedure for your hematocrit determination. Okay, then we have also here the ESR or the erythrocyte sedimentation rate. Erythrocyte sedimentation rate is actually one of the tests as one of our acute phase reactant. Acute phase reactants are substances which are used here for evaluation the presence of your inflammatory reactions. So lahat ng inflammatory reactions, they would tend to increase the result. Meaning to say, this ESR is a non-specific na test. So kahit anong inflammatory reactions inside the body of the patient, this one will give an increased na result. Okay, so the ESR is just measured here as the degree of the settling of the RBC after 1 hour. So 1 hour reading time natin. So just measure here how fast the RBC try to settle. So ganito lang siya. So pag finil mo dito ng blood natin, so bababa ang RBC, tatay mo lang kung kailan sila lahat. Or itatay mo after 1 hour kung ano ang degree of the settling process. Okay, so basically the RBC, nagsisettle sila because normally ang RBC natin contains here a negatively charged na particles. So may mga negatively charged dito. And this negatively charged particle here or the zeta potential, the zeta potential is actually the one that would allow the RBC here to repel one another. So, hindi sila mag-stick to one another. But if you try to destroy the negatively charged here because of the different factors, okay, ito yung mga factors na I will discuss this later on. Okay, that would eventually result here to the settling of your RBC. Okay, we have here the stages of the ESR. So basically, we have here 1 hour time, 1 hour reading time. So that's why 10 minutes, 40 minutes, and we have here 10 minutes. So give you here 1 hour time for the settling process. Okay, the first stage, we have here the lag phase. This is characterized here by the initial rouleau formation. So again, for the RBC to settle, then they need to form rouleau formation first and then try to settle. Pag hindi sila nag-form ng rouleau formation, they will not able to settle. The next one, decantation phase, is the next 40 minutes, is the period here of rapid settling process. And the last 10 minutes here is a period of the final settling, where majority of the RBC is already at the bottom here, making this one as a slower settling process. Since andito na sila sa baba, edi wala silang, di ba? So, medyo slow na, kasi wala naman silang pupuntang iba. Okay, we have here the different factors that actually try to determine the result of our ESR. The first one, we have here the RBC factor. The first one, we have here the number. Okay, for the number of the RBC, so the number of the RBC here is inversely proportional to the result of the ESR. Mean to say pag, okay, like this one, madaming RBC, mean to say that your polycythemia vera, since madami sila, mahirapan sila magbaba. Okay, therefore decreasing the ESR result. Pag anemic ang patient natin, so wala siya masyadong RBC, di ba? Pag wala ka masyadong RBC, so wala silang kakompetensya pagbaba. And therefore, that would allow them to have here a faster ESR. In the case pag mababang ating RBC count in the case of your anemic patient. For the size, that one is directly proportional. I mean to say, the bigger the size, pag mabigat siya, so mabilis siyang bumaba. Okay, pag macrocytic compare with your microcytic, di ba? So, pag macrocytic, mabilis ang ESRs, mabilis ang ating sedimentation. For the shape, so pag abnormality in the shape, the serpoikilocyte that would inhibit here the rouleau formation. So, therefore, pag walang rouleau formation, mahirapan silang mag-settle. And therefore, decreasing the ESR result. Okay, viscosity, so lapot ng dugo. So the more viscous it is, the more lapot it is, mahirapan siyang mag-settle. Then we have also your other factors. We have here the plasma proteins and some of your lipids. Okay, for our plasma proteins, your fibrinogen, your alpha-1 and alpha-2 globulin would tend to increase the ESR result. Albumin, on the other hand, would tend to decrease the result, along with your lipid na lecithin. But your cholesterol tend to increase the result. Okay, technical factors. Number 1, temperature. Okay, ideal temperature here for the ESR would be at room temperature. That's 22 to 27 degrees Celsius. So, increased temperature would tend to increase the ESR result. Cold temperature, mahirapan siyang mag-settle. That would decrease the ESR result. Another one, inclination of the tube. Okay, so pag ganito ang ESR natin, pag i-incline natin ganun, i-tilt natin ang tube natin, mabilis ito mag-settle here because, okay, so, ang, instead, pag ganito kasi, medyo di ba, ganyan. Okay, so pag ganito, okay, pag ganito ang ating tube natin, so pag, okay, allow the RB to settle here, so medyo malayo, di ba, malayo, ang kanilang, okay, the distance for them to travel here before they try to settle at the bottom. Pero pag in-incline natin, so, okay, shortcut na lang sila, therefore, mas faster ang ating sedimentation. So we have that one, tilting the tube here, 3 degrees, would have here equivalent 30% na increase in the ESR result. Okay, the bubble formation would tend to increase the results. Okay, for example, kung itong RBC natin, ganyan, pag may bubbles dito, ano mangyari? Pag pumutok ang bubbles natin, wala nang bubbles, okay, di mabilis na siya. Ganun na siya. Okay, then we have also here the diameter, the length, the wider the diameter, the longer the length of the tube here, the faster the ESR. Okay, then we have here the anticoagulants. Okay, over anticoagulation, that would eventually result here to your decreased ESR result because of the sphering of the RBC. Pag sphere ang RBC natin, mahirapan siya mag-relow formation. In the presence of your heparin, sodium oxalate, potassium oxalate, would tend to result to the shrinkage of the RBC. Pag maliliit ang RBC natin, so, okay, that would eventually result to your ESR. Hala. Okay, I think mali. Sa book kasi ma-increase ang ating ESR. But if you think that one, kung pag nag-shrink ang RBC natin, maliliit sila, so I think mabagal ang ESR natin. Okay, then we have also here the method for determination of the ESR. So you can use here the original Westergren method. Original Westergren method here make use of the Westergren tube. So that one, the reading time for that, however, here two reading time, one after 1 hour, the other one is after 2 hours. Anticoagulant used for that is your 3.8% sodium citrate. That's your black top tube na citrate. That would have your 1:4 na anticoagulant blood ratio. Not your blue, light blue na 1:9. But rather, the black top tube here that would have your 1:4 anticoagulant blood ratio. Currently, we have here the modified Westergren, which is being recommended by the International Committee for the Standardization in your Hematology. So this one would have only 1 hour reading time. So after 1 hour, you read the result. So anticoagulant, na pwede natin gamitin for that, we have for your, still with your 3.8% sodium citrate, we have also your EDTA or pwede na ating 0.85% na sodium chloride or simply your NSS. The Winthrop tube here would eventually uses here the anticoagulant na double oxalate and that is being read here after 1 hour. Could also use EDTA for that. Okay, we have here the difference between your Winthrop tube and we have also your Westergren. Okay, so your Winthrop tube, ito kanina yung ginamit natin sa macrohematocrit. So ito yung side na gagamitin natin. We have here 0 on top and 10 at the bottom. Again, that gives you 100 na, okay, 100 millimeter na graduation. Okay, so Winthrop tube here would have 3 millimeter na diameter na tube versus your 2.5 millimeter with your Western grain. Graduation mark for the Winthrop up to 100 compared with the up to 200 with your Western grain. The coagulant of oxalate versus your 3.8% sodium citrate. Sensitivity, your Winthrop tube is less sensitive because of the short column compared with your Western grain would have your more sensitive. What do you mean by that? Okay, like this one, up to 100 lang siya, di ba? What if, for example, after 1 hour, mabilis mag-settle ang blood na or RBC ni patient natin? So, kung ang ginamit natin na tube is the Winthrop tube, ang maximum na reading mo lang is up to 100 mm. So, we don't know, let's say, dapat after 1 hour ang reading mo, pero hindi pa natapos ang 1 hour, nag-settle na sila agad-agad. Ang bilis ng settling process, still ang reading mo dito is 100 pa din. It's because na hanggang 100 lang ang maximum na graduation natin. Where in fact, kung itong ginamit mo, Western grain, you could have here beyond 100 mm na reading. It could have here up to 200 kasi ang kanyang graduation, making that one is more sensitive because of the wider, longer na graduation column reading here compared with your Winthrop. Okay, another method here. So, ang procedure lang nito ay mag-fill ka lang ng blood dito. Okay, and then let your blood, your tube here, allow it to stand at room temperature for 1 hour. Okay, dapat straight lang ito and do not disturb. Because again, pag nag-vibrate, di ba, kung mamove mo ito, it would affect the settling process. So, dapat hayaan mo lang siya in part of your laboratory na hindi siya nadidisturb. Okay, then after that one, i-read mo lang dito kung saan siya pumunta. Dito ba? Ganyan. So like for example, this one is 0, this is your 1, 2, 3. So for example, after 1 hour, so 4. Dito siya sa 4. Since each of this one would have your smaller graduation mark, so ang ating reading is mm per hour. So kung nasa 4 siya, this give you 40 mm per hour. That's your way of reporting your result. Okay, we have here another method for the ESR termination. We have your automated na method for the ESR determination with the use of your Osmotic 20. This is a benchtop analyzer that would allow you to measure the ESR. So this one uses here the 8 slant, degree slant that would allow your RBC here to undergo sedimentation or settling process. At ang mag-read niyan is the optoelectric sensor of this instrument. Okay, another method here for the ESR termination, we have here your zeta sedimentation rate. Okay, the zeta sedimentation rate measure here the degree of your settling process after 4 cycle of your centrifugation. Each of the cycle contains here 45 seconds. So, 4 na beses mo siya i-centrifuge. Only that, this one uses here special na hematocrit or tube in the form the zetacrit. Tapos ang kanyang centrifuge is in the form the zetafuge. Then after 4 cycle, you try to measure here the degree of, okay, the packing here as, okay, percentage of your hematocrit, the original, with your blood, and we have also here the, okay, the degree of the packing here, or the zetacrit after 4 cycle of the 45-second centrifugation. Multiply by 100 that eventually become here your zeta sedimentation rate. Okay, then we have here the normal values. So, pag nag-measure ka dito sa knee area, okay, usually kasi dapat, pag nag-measure tayo, dapat straight siya, di ba, ganyan. Minsan, however, ganyan ang magiging degree of packing. So, dito ka sa gitna, kung saan parang knee area niya, doon ka magme-measure ng ating hematocrit for that. In the case of your zeta sedimentation rate. Okay, then we have here the normal values for your ESR. For the female here, the 0 to 15 mm per hour. Okay, for the male and among children, the 0 to 10 mm per hour. So more than 90 mm per hour, so sobrang bilis niya. Okay, that may be found here in your polymyalgia and rheumatica and temporal arteritis. Okay, then we have here the case study. So, granting here, for example, you perform here your ESR, then you try to place your ESR tube here above your refrigerator. What will be the expected na result with the ESR? Number one, you're going to have here falsely decrease na ESR because nasa ref siya because of lumalabas ang lamig sa ref. Remember here that the temperature, decreased temperature would have decreased na ESR result. Another result here, increase na ESR, that may be because of due to your vibrations of the ref. Maganda ng ref natin, so expect na mabilis ang kanyang settling process. The third one is falsely increase related here to the heat emitted by your refrigerator. And remember here that the higher the temperature, the more or the faster the ESR result. So this would be the possible na result pag ganito ang setup natin. That's why dapat, saan natin ilalagay, you need to put your ESR tube here in the test tube rack or in a position that one is not being disturbed within 1 hour in order for you to measure the settling process. Okay, in the last one, we have here your osmotic fragility test. Osmotic fragility test measure here the ability of our RBC membrane to withstand under pressure when they are exposed here in the hypotonic solution. Normally, ang RBC natin are able to maintain their shape once they are in the isotonic solution. But once they are in the hypotonic solution, they try to absorb the water, they try to swell, and eventually try to burst. So this test would measure ability of your RBC kung kaya niya i-tolerate ang ating hypotonic solution. Gumagamit tayo dito ng ating solution in the form of your 0.5% na sodium chloride. Isotonic solution is nasa 0.85 to 0.9%. So 0.5 is already below that one, so that's already hypotonic solution. Okay, we have here the method for the osmotic fragility test. We have here your Sanford. So for this one, you're going to prepare 12 na test tubes. Label that one as tube 25 to tube number 14, starting on your left, in my left. That become your tube number 25 and up to tube number 14. Okay, so ito magiging content ng kada tube natin. Okay, we have here the drop of your 0.5% sodium chloride. We have here the drops of your NSS. And we have here the number of the drop of the blood. So procedure for this one, tube number 25 contains 25 drops of your 0.5% na sodium chloride, wala kang ita-drop na NSS. Tube number 24, 24 drops. Okay, tube number 24, 24 drops na 0.5% na sodium chloride and 1 drop of your NSS. That gives you 25 drops. Okay, then we have here 23 drops, tube number 23, 23 drops of 0.5% sodium chloride and 2 drops of your NSS and so on. Then you extract the blood, okay, with your syringe. And from the syringe tip, okay, the-drop mo siya directly. So, ganun mo yung syringe natin, magda-drop ng blood dito sa tip ng syringe. Okay, so each of this one, you try to add 1 drop of your blood and try to shake. Okay, and then try to incubate at room temperature for 2 hours. Then do not disturb. Okay, then we have here for the interpretation of the results. So we're going to take here dalawang result. One will be the initial hemolysis. Okay, initial hemolysis here, the first tube from the left, it shows here faint pink na plasma with not so compact na sediment. On the other hand, your final hemolysis here, complete hemolysis, primarily is the first tube from your left, which has this red na plasma and without your compact sediments or without sediments. Wala na siyang compact sediment here because majority, or meaning to say lahat, ng RBC natin ay nag-rupture na. And therefore, wala ka ng compact sediments. So, ganun lang siya. So, like for example, okay, so Okay, for example, dito siya. Okay, so if for example, clear. For example, dito, 24, 23, 22. Pag sinabing first tube from the left, so we're talking about the left here. So, titignan mo dito kung alin, pag initial hemolysis, tignan mo dito kung saan may medyo faint pink, mean to say nag-hemolyze na siya, pero meron pa rin siyang sediment dito sa baba. So, mean to say, ang previous na tube nun dapat ay clear pa siya. Wala ka pang hemolysis. Pag final hemolysis naman, hanapin mo dito, okay, dito sa first tube from your left, okay, na wala na siyang sediment at puro red na siya. Mean to say, ang previous mo na tube for that ay may red na siya pero may sediment ka pa. So, mean to say, pag final hemolysis na or complete hemolysis, dapat red na siya, wala na siyang sediment. And therefore, ang next mo na mga tube ay wala na ring mga sediment. Okay, then we have here the normal. Normally, ang ating initial hemolysis fall here between tube number 22 and tube number 21. To get here kung ano ang concentration ng sodium chloride natin, that equivalent to kung saan siya nag-hemolyze, multiply the tube number by 0.02. Okay, like for example, tube number 25. Okay, tube number 25 multiplied by 0.02. Okay, that give you 0.5. Tama ba? 0.5%. Why 0.5%? Notice here na tube number 25 natin, ang content nilang naman ay lahat 0.5% na sodium chloride. Wala ka nilagay na NSS. Okay, so therefore, to get here the concentration of the sodium chloride, just need to multiply ang tube number by 0.02. Example, for the tube number 22, ilang percent na sodium chloride yan? Multiply by 0.02, that's give you 0.44% na sodium chloride. Okay? For the final hemolysis here usually is nasa tube number 16 or tube number 17 siya dapat. Okay, that equivalent to your 0.32% na sodium chloride or 0.34% na sodium chloride. Okay, then we have here the clinical correlation. So we have siderocytes, parasites, characterized here by decreased surface area volume ratio that would decrease your osmotic fragility test. Target cells, sickle cell, hypochromic cells, increased surface area volume ratio, and characterized here by the decreased na osmotic fragility test. Okay, thank you.